week 7, we began a conversation about the properties of real numbers. After using closure property to perform operations on each of the subsets of real numbers, it was time to talk about the real numbers as a whole. The properties that we discussed in the beginning of week 7 were the commutative properties of addition and multiplication, and we started to have a conversation about the inverse and identity properties, but in the first part of the week, we focused on the commutative property. The essential question that we had to ask ourselves was, does the order in which we add or insert any operation in here, numbers, affect the result? Okay? So really, does order matter? Here we have is 3 raised to the 5th power equal to 5 raised to the 3rd power. So we switch the order or the position of these two numbers, and we're still working with exponents, but we see that 3 times 3 times 3 times 3 times 3 is not equal to 5 times 5 times 5. We can verify that by saying 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, and 81 times 3 is 243. 5 times 5 is 25, and 25 times 5 is 125. So 243 and 125 are not equal to each other, and that's enough to say that the order in which we exponentiate numbers does matter. For multiplication, we ask, is 3 times 5 equal to 5 times 3? Well, if 3 times 5 is 15, and 5 times 3 is 15, then it doesn't seem to matter what order we multiply numbers in. For division, we ask, is 3 divided by 5 the same as or equivalent to 5 divided by 3? And what we get is a fraction, 3/5, which is less than 1, is not equal to 5/3, which is greater than 1. Now, we begin a conversation about the relationship between 3/5 and 5/3, and some students will be able to tell you that 3/5 is the reciprocal of 5/3, or 5/3 is the reciprocal of 3/5. For addition, we say, is 3 plus 5 equal to 5 plus 3? Well, 3 plus 5 is 8, and 5 plus 3 is 8, and because 8 is equal to 8, we can begin to conclude that the order in which we add numbers does not affect the result. For subtraction, we ask, is 3 minus 5 equal to 5 minus 3? Well, 3 minus 5 is negative 2, but 5 minus 3 is equal to positive 2. Because negative 2 and positive 2 are on opposite ends of 0, the students conclude that they are opposites. So negative 2 and positive 2 are opposites of each other, and the order of which we subtract numbers does affect the result. So here, when we try to generalize these ideas, we say, instead of using the numbers 3 and 5, we can use variables that represent any numbers. So any numbers A and B, right? If I multiply A times B, the product should be the same as when I multiply B times A. We can summarize this idea by saying that the order in which we multiply numbers does not affect the result, and that is actually the commutative property of multiplication, where commute means to move things around, and multiplication being the operation that we're allowed to move things around freely. We do not have a commutative property for division, but we do for addition. So here we see any number A plus any number B is equal to or equivalent to any number B plus any number A. We summarize this by saying the order in which I add numbers does not affect the result, and that is the commutative property of addition. So it is important when the students talk about the commutative property, their ability to move numbers around operations, they don't just say commutative property, they say the commutative property of multiplication, or they say the commutative property of addition. It's also important to recognize and remember that we don't have a commutative property for division, because when I divide numbers in different orders, I get reciprocals, and we don't have a commutative property for subtraction, because when I subtract numbers in different orders, I get opposites.